Hello, my dear students. I am Aditya Chakraborty, lecturer in electrical engineering of Sri Ramakrishna Institute of Science and Technology. Today, I am going to discuss about the different types of lightning arrestor or the classification of lightning arrestor. Today is the part 1 or the first part of my lecture is demonstrated here. So, before going to the classification, we have to know that there are several types of lightning arrestor in general use. They differ only in constructional details but operate on the same principle, providing low resistance path for the surges to the ground. So, the various types of lightning arrestor are: first one is a rod gap arrestor, second one is the horn gap arrestor, number 3 is a multi-gap arrestor. The fourth one is the expulsion type lightning arrestor. The fifth one is the valve type lightning arrestor. The sixth one is a silicon lightning arrestor. And the last one is the metal oxide arrestor. So now, the first one is the rod gap arrestor. It is a very simple type of arrestor or diverter and consists of two 1.5 centimeter rods which are bent at right angles with a gap between as shown in the figure. In the next slide, one rod is connected to the line circuit and other rod is connected to the earth. That means one rod is connected to the live line, another is connected to the earthing. The distance between the gap and the insulator is denoted by the P, must not less than 1/3 of the gap length so that the arc may not reach the insulator and damage it. So the distance of the P is not less than 1/3 of the gap length. Okay. If it is occurred, then the arc or the spark between the gap damaged the insulation resistance of the insulator. Generally, the gap length is so adjusted that the breakdown should occur at 80% of spark voltage in order to avoid the cascading of very stiff front across the insulator. So, the breakdown should occur at 80% of spark voltage, and in order to avoid the cascading, the steep wave front or across the insulator is provided. The string insulator for an overhead line on the bushing of the transformer has frequently a rod gap across it. And the next slide we can see the figure of the bushing or the bushing of the transformer which is connected with the transformer tank. And here the rod gap across the bushing of a transformer. Under normal operating condition, the gap remains non-conducting. So there is no current or there is no arc is produced between the gap under normal operating condition. On the occurrence of high voltage surge on the line, the gap sparks over and the surge current is conducted to earth. In this way, excess charge on the line due to the surge is harmlessly conducted to the earth by the earth conductor. So now you can see the image of the rod gap arrestor here. So that is the transformer tank, and the transformer bushing insulation or the insulator of the transformer bushing where the primary winding is connected, or the supply terminal is connected with the transformer bushing, and that is the line. Okay, that is the rod connected to the line, and that is the rod gap, and this side of the rod is connected to the earth, and that is the P between the rod and transformer bushing. The distance is P. Okay, it must be greater than the distance of the rod gap, otherwise the sparking or electric arc damaged the transformer bushing or the insulation. Now the limitation of rod gap arrestor. After the surge is over, the arc in the gap is maintained by the normal supply voltage, leading to short circuit on the system. So what will happen? When the surge is over or when the line is healthy, the arc is not extinguished because there is no arc extinguishing medium used in the rod gap. So it is maintained by the normal supply voltage and leading to short circuit on the system. The rod may melt or get damaged due to excessive heat produced by the arc. If the arc is produced, then there is a I square R loss is produced in the air, and due to huge amount of heat, the rod may be melt or get damaged. The climatic condition affects the performance of the rod gap arrestor, like rain, humidity, temperature, etc. And the polarity of the surge also affect the performance of this arrestor. Due to the above limitation, the rod gap arrestor is only used as a backup protection in case of main arrestor. So it is not acting as a primary protection. It is act as a backup protection or secondary protection with another arrestor or with the main arrestor. Now the horn gap arrestor. It consists of horn-shaped metal rod A and B separated by a small air gap. The horn are so constructed the distance between them gradually increases towards the top, as shown in the figure in the next slide. So the distance between two horns are not same. The horns are mounted on the porcelain insulator. One end of the horn is connected to the line, resistance and choke coil L, while the other end is effectively grounded, just like the rod gap arrestor. But the difference is that in one end of the horn there is a resistance and an inductive coil is used to limit the current. Actually, this RL circuit is used to limit the current, or this reactor and this resistance is used to limit the current, or you can say that the reactor is a current limiting reactor which is connected to the one end of the horn. The resistance R helps in limiting the flow of current to a small value. The choke coil is designed that it offers small reactance at normal power frequency but a very high reactance at transient frequency. So what I have told as earlier are that the choke coil is to design such a way that it offers small reactance at normal system. So if there is a small reactance at normal or healthy condition, it opposes a small amount of current, or it limits a small amount of current. But when the transient frequency has come, then the reactance is very high, so it limits the huge amount of currents. Thus the choke does not allow the transient to enter the apparatus, and it is and this apparatus is protected. The gap between the horn is so adjusted that normal supply voltage is not enough to cause an arc across the gap. So during the normal or healthy condition, the normal supply voltage is not causes any arc between the horn gap. Under normal condition, the gap is non-conducting. So it is non-conducting, no current is flowing through that. That is, normal supply voltage is insufficient to initiate the arc between the gap. On the occurrence of an overvoltage spark over takes place across the small gap G. The heated air around the arc and the magnetic effect of the arc causes the arc to travel up the gap, and the arc moves progressively into position 1, 2 and 3. At some position of the arc, that is position 3, we can see in the next slide in the figure of horn gap arrestor, the distance may be too great for the voltage to maintain the arc. Consequently, the arc is extinguished. The excess charge on the line is thus connected through the arrestor to the ground. Here you can see a horn gap arrestor image. The line to apparatus to be protected, that is the choke coil, which act as a inductive coil, and the inductance is high when the transient frequency has come, that is the resistance, and that is the horn gap. You can see here 1, 2 and 3 position, and these are the horn shape metal, that is earth. So that is the gap. So at first the surge is in 1 position, after that 2 position, and after the 3 position it is extinguished. So you can see here the gap between this A and B2 part of the horn is increased from 1 to 3 position. Okay, so that is the horn gap arrestor image. That's all for today. Thank you.